Hello and welcome. Welcome to a memory jogging session. This series of notes captured on video is to help me remember progress on my latest project. Converting a mini bike sidecar outfit for my grandson Noah into electric version of the same project. It originally had a 50cc two-stroke engine, but that's too advanced for my young grandson at present. He's just a toddler, so how do I enable him to enjoy the project as it is and maybe include a bit of movement, all done with utmost safety in mind? Well, the obvious choice is an electric motor. There's lots of them about now. Everybody being encouraged to motorise the cycles, push bikes, skateboards, everything you can imagine. So I purchased a kit which was obviously taking a chance that it would do the job, but anyway, I purchased a kit, 250-watt motor designed to power a 28-inch push bike bicycle wheel. This motor had a gearbox, unknown ratio, but I assumed it would do the trick of moving an adult on a bicycle at a slightly faster speed than they could pedal, and hopefully move it from a standing start. That was the ballpark criteria I gave myself. Then I had to decide what voltage. Being familiar with radio control stuff, I know how dangerous some of the batteries are and how quickly depleted they are on things like drones. I wasn't expecting it to be an endurance machine, but I wanted a few minutes running without charging any batteries, and I wanted these batteries to be safe as possible. Being able to be taken off the sidecar outfit, charged up, and then attached to the sidecar outfit somehow. and have it easily usable. The kit I purchased has a throttle, which is a variable speed controller. It has a key for ignition switch. It has a brake so you can cut the power, and it has some lights. On the instrumentation, I want to be able to see the voltage of the battery as it is fitted, and the voltage monitored so that I can decide when to take the battery off and charge it. I guess having multiple batteries at the same time is the obvious choice. So what was I going to use for a power supply? Well, after researching batteries, I settled on a 24 volt battery from a cordless drill. They're relatively cheap, charge up reasonably quickly, certainly safe, and they don't have any risk to the user that can be avoided with a bit of safety thought. To a reasonable size, certainly safer than, let's say, a 12 volt car battery. Because the Sidecar outfit has, by its very nature, a sidecar, this is an obvious choice. Apart from carrying teddies and toys up and down the garden, it could carry the voltage, i.e. the battery. So I found a cordless drill for sale, complete with a battery and battery charger. I researched similar models and purchased multiple batteries and a second charger, so I ended up with 4 batteries. 24 volts was the power I settled on. And I thought a lot of these drills have a lot of torque, so it'll be used to giving a few amps under load, i.e. when the Sidecar outfit goes away from rest. So the idea would be cut off the insides of the cordless drill just above the quick connector. Discard the rest of the drill, have a look inside it for another project another time. Mount this part of the handle and quick connect into the Sidecar, and I invented a swivel so that the battery swivels up to change it, and then swivels down for stability and safety. I'll eventually run the wires out of this quick connect to the motor speed controller, and jumping ahead slightly, I've got a step down board for voltage control, and I'm going to use that so that the 24 volts, which is handy for the battery, essential in fact, can be stepped down with this variable voltage control. Using a voltage step-down controller to go from 24 volts to under 9. Can be stepped down to lower voltage. A voltage I'm aiming for is round about 7.2 to 9 volts, which will run equipment such as a high torque servo. I'll come to that in a minute. So the batteries, the motor controller, the throttle, all connected up. Not attached to the bike, of course, at this point. All connected up. And it all went smoothly. First time I've seen the electric motor output shaft through the gearbox, and I started to get a feel for what the gear ratio was going to be. Noah's bike goes electric. I settled on buying a blank large rear sprocket of the same chain size as what came with the electric motor. It was a 420 chain, which is quite beefy, but there's some forces involved with this, so I didn't want any failings with the chain. I would rather over-engineer it at this point. I'm only aiming at a few miles an hour for this vehicle in this stage. It is, after all, for a toddler. Speed will come later. So the large sprocket came. I settled on drilling the rear disc brake and mounting the sprocket to that. I don't think this bike needs a rear brake. It's got twin front disc brakes, and that'll do for the speeds involved. And it's just two hand controls, one for the electric brake and one for the mechanical brake, for the disc brakes. So two brakes, one throttle, sounds about right. Attaching the chain, tensioning it, attaching the motor to the frame, chassis, time to spin it up. So I lifted the back wheel off the work surface so it was supported during the test. Powered up the battery, or should I say the battery powered up the motor, turned the ignition on, twisted the throttle, and it moved the back wheel as it should. Thoughts racing at this point. What speed is it going to do? Ignition on. 25-volt battery. Throttle. How do I measure it? Well, a strobe was the obvious answer. Strobe tachometer. Found a suitable app for my iPhone 11 and a blob of paint on the front sprocket of the output shaft from the gearbox. Started the app up, pointed the camera of the phone at the object, i.e. the sprocket, turned off the room light, twisted the throttle, and lo and behold, the strobe. The principle of the app was to adjust the app variables until the strobe became stationary, or rather the pointer on the output shaft gearbox remained stationary, or appeared to remain stationary. I managed this after a little bit of fiddling. I got the revs, which we'll see in the video, and I was able to calculate the speed from knowing the circumference of the back wheel, the gear ratio between the back sprocket and the front sprocket turned out to be 5:1. So I was able to calculate with a few simple maths the speed, and lo and behold, it was the magic 3 mile an hour that I was looking for. Fantastic. Time to think about further innovations of the project. Finding methods to adjust the chain or move the motor. I've gone for a solid rear axle, solidly mounted in this swinging arm that doesn't swing. So the next innovation was, why not have a radio controlled servo turn the handlebars by pushing and pulling against the fork leg or the yoke. Radio controlled steering. I didn't want a lot of angle on the steering, but I wanted it to give the rider, young Noah, a feel for turning handlebars to change direction, because that's what this project's all about. Starting off an experience with a motor vehicle, albeit electric motor, with a throttle. So, digging through my spares, I came across a high torque servo motor. I'd used this type of thing on quite a few projects in the past, but I still wasn't sure whether it would have the torque to push or pull the steering to turn the handlebars enough. Bear in mind that this might be ridden in a garden, which isn't necessarily ballpark flat. So there's a little bit of torque involved. And that's where I am at the moment, developing the radio control servo mounting linkage and ratio of linkage so that it does what it's supposed to do. Thanks for joining me on this long-winded discussion of how to develop a mini motorbike and sidecar for use by a toddler. Thanks for watching. Join me again soon. in the next episode where will be more development. Bye.